Good morning, students. So in the previous videos, we have discussed about the combustion process in SI and CI engines. So once you come to know the combustion process in engines, so at the same time one more very important drawback is there, that is phenomenon of knocking. Okay, so that is also called as a phenomenon of detonation in SI engines. This is one very important topic. This is also, so knocking, or it is also called as a detonation in SI engines. Okay, so I think all of you heard that practically if you see any engines like 4-stroke or 2-stroke engines, so somewhere during the combustion there is a unpleasant sound will going to arise. So that sound is because of this detonation or the knocking effect in the engine cylinder. So how that knocking process or the knocking will going to happen in the engine cylinder, so we'll discuss briefly here. So you just go through this figure or the graphs or the diagram, so what I given here. So first I'll going to consider the two diagrams here. First one is the A diagram and the B diagram. This from the A diagram, if you understood, this is the engine cylinder. Okay, so it is completely represents the engine cylinder, that is SI engine cylinder. So this is a point represent, it is a location of the spark plug here. Okay, it is at the TDC portion. Okay, this A point indicates the location of the spark plug, and D point is the last TDC point, that is a BDC, but that is a bottom dead center. And here there is one hashing portion area is there, that is B dash and D. This is some charge or the mixture of fuel air mixture is there here. Okay, I'll explain in detail how this. Okay, you just consider that this complete circle type sketch or the diagram, it represents the engine cylinder. A point is the location of the piston and D point is the bottom dead center, and this B dash and D is the some amount of that is fuel air mixture is there. So that is the thing. And at the same time, so this diagram, it will indicate the normal combustion process. Okay, so here there is no knocking. Okay, at the same time, for that I drawn the graph here, the pressure versus time versus that is the pressure and time versus indicator diagram I drawn it here, that is the compression, combustion and expansion will there. Okay, this is a normal. By seeing these two diagram, that is diagram A and B, it indicates the normal combustion process in the SI engine. Here I am not explaining knocking. Okay, so I'll just explain you how one more time how this normal combustion will takes place. So in the normal combustion process, what will happen during the knocking? The auto ignition of the portion of the unburned charges at the end of the combustion process will take place. So I'm just explain that normal combustion. So here consider the figure A and B. Okay, let's show that normal combustion. In normal combustion, the flame front formed by the spark plug. Okay, so flame front means what? The flame will get produced once the spark will get ignited. Once the spark will produce in the engine cylinder, that whatever the air mixture is there nearby the spark plug, it will get burnt, start burning, and it will produce the flame. Okay, so that flame will travel across the combustion chamber from the point A to D towards the D point. Okay, so as the flame front proceeds, it reaches the energy, releases energy to charge the near to it and results in the combustion of the air fuel mixture. Okay, so as during the moment of this flame front from the A to D, so whatever the fuel mixture is there, that will transfer the energy, heat energy, and will starts increases that remaining fuel air mixture. Mixture. Then the advancing flame front compresses the end charges, that is B dash and D farthest from the spark plug, thus raising its temperature. the temperature of end charge also increases due to the transfer of heat from hot advancing flame front. Okay, so in spite of these factor, if the temperature of the end charges had not reached the self ignition temperature, the charge will not auto ignite and the flame front will advance further and results in the combustion of the n charges, that is B, B dash and D. Okay, this is about the normal combustion. So next, if you come to consider this another figure, that is C and D. So this is also engine cylinder. Here at the end point there is a two portions are there, C, C dash and D, B, B dash and D. So here at the same time this indicator diagram by considering pressure and time, so this will slight change. There is one here zigzag type portion is there in the graph. So this indicate that knocking. So how this knocking will takes place in the engine cylinder, I will explain in this paragraph here. Just see here, you just consider the figure C and D. It shows it is an abnormal combustion process. So during the abnormal combustion, the temperature of end charge B, B dash and D reaches auto ignition temperature before the flame front reaches the end charge. Okay, so what is the abnormal combustion means? The temperature of the end charge. So whatever that fuel air mixture is there in the portion, that is B, B dash and D, it will reaches its auto ignition temperature. Okay, so once it will reaches its auto ignition temperature, so it will starts burning. Okay, so before that flame front will come from the spark plug. Okay, so the end charge B, B dash and D will auto ignite and results it releases energy at a rapid rate and also results in the formation of one more flame front which travels in the opposite direction. Okay, the collision of two flames front causes the pressure differentials in the combustion chamber and the high pressure wave is released. The motion of the high pressure wave inside the cylinder causes the vibration of the engine parts and the pinking noise called detonation or the knocking. Okay, so this is what the knocking. So that's why this in the graph it is shown as a zigzag line here. So I will in brief I will explain one more time. So in the normal combustion, the spark will produce by the plug and then it will produce the flame. Okay, that flame will travel from point A to towards the D point. So as that flame will transfer its heat energy to the neighboring fuel air mixture, then the burning will start. Okay, so sometime what happen, whatever the charges is there at the end portion, that is B, B dash and D, it will not auto ignite. So automatically again that flame will travel further and it will ignite. So at the end, so the combustion will takes place. In the same way, so as some amount of fuel air mixture is there at the end portion, that is B, B dash and C, so then automatically this will get ignited, auto ignited before that flame will come from the spark. Okay, so automatically this charge will get auto ignite and will produce one more pressure wave that will start traveling in opposite direction towards the spark plug, and wherever the two waves flame front will get collide, then a huge quantity of pressure wave will get generated and it will produce the noise. So that's why in the graph it shows in the zigzag way, because there is no normal variation in the pressure or anything or the velocity, it is abnormal. So the more noise will get produced in the engine cylinder. So that process is called as a knocking or the detonation in the engine cylinder. So for this, some parameters or the factors are there, that factors will affect this detonation or knocking in the SI engine. So briefly we will discuss about those parameters. So here I am listed some factors here. First factor is the compression ratio, second one is the location of spark plug, engine size, inlet temperature of the mixture, self ignition temperature of the fuel, and temperature of combustion chamber walls. So these are the main very important parameters or the factors which will affect on the this knocking or the detonation or in SI engine. So how this compression ratio affects? The pressure and temperature at the end of the compression increases with increase in compression ratio. The tendency of knock increases with increasing in the compression ratio. If the compression ratio increases, at the same time the knocking also increases. And location of the spark plug. The spark plug in a combustion chamber is to be located in such a way that distance traveled by the flame front to reach the end charge is small. Okay, the distance between the location of the spark plug and the charges where that fuel air mixture is there is very small. So in such a way that we can place the piston that is spark plug in the engine cylinder head. Engine size. The size of the engine does not have much effect on the rate of flame propagation. In large engines, the flame front has to travel longer distance. Therefore, compact size engines are desired to avoid the detonation or the knocking. Then inlet temperature of the mixture. Increase in the inlet temperature of mixture increases the temperature at the end of the compression and thus the increased tendency of detonation. Self ignition temperature of the fuel. Fuel with the high self ignition temperature are less detonating. The temperature of the combustion chamber walls. The temperature of the combustion chamber walls play an important role in detonation. In order to prevent the detonation, hot spots are to be avoided in a combustion chamber. Cooler combustion chamber walls have fewer tendency to knock. So this is about the factors which will affecting the knocking in SI engines. So this is they may here in this topic you may arise two questions. They may ask in the exam explain the knocking process or detonation process in SI engine, or they may ask one more question on this is so you can list and explain the various factors which are influence on the knocking. Okay, so this is about the factors and the knocking process what you going to explain. Okay, so this is about the knocking in the SI engine and the factors which are affecting on the knocking you will discuss it. Okay, thank you.